Greetings, everyone, and I trust you are all well. Welcome to my YouTube channel for Kangaroo Medicine Science Academy, where I'll be taking you through the differential calculus, particularly on optimization and the rate of change. Right. While sharing the slide, kindly don't forget to like and subscribe. Thank you. Right. Then now, in this slide, I'll take you through optimization and the rate of change. But particularly, I will emphasize on optimization, then the rate of change will be dealt with in the next video session. All right. Under optimization, first of all, what is it that we need to know? At the end of this session, you must be able to understand what we mean by optimization and what are the pre-knowledge, like for you to be able to apply optimization using calculus. And one other thing is the issue of the rate of change. Right, number one, what do you mean by optimization? Optimization is the process of finding the maximum and the minimum value when given constraint using calculus. So in other words, when we are dealing with optimization, we actually want to maximize or we want to minimize a function given its constraints. Yeah, so this is what you need to understand actually when we're dealing with optimization. It has to do with maximization or minimization. Then another thing, by a pre-knowledge, one must be able to understand how to determine the perimeter and the area of two-dimensional objects, such as rectangles, such as square, such as circle, and triangle. It's very important. And again, you must be able to determine the surface area or total area and the volume of 3D objects. And when we talk about 3D objects, we are referring to objects like rectangular prism, the cylinders, a cube, a right circular cone, and other shapes. All right, then again, you must be able to find the derivative of a function with respect to its specific quantity. And what do we mean by the derivative in calculus? Remember, calculus, especially in differentiation, we have learned how to determine the derivative of a function at a point. And this has to do with gradient at one point, which you call it the dy over dx, which is the derivative of function y with respect to x. Or we can use f prime x, which is just the derivative of a function f with respect to x, which has to do with a gradient at a point, or a gradient function actually at a point. Then again, you need to familiarize yourself with the second derivative test, which has to do with concavity and the local maximum or the minimum in terms of turning points. However, we're not going to spend more time on the second derivative. We'll address more on the issue of finding the area, the perimeter, the areas, surface area, the volume, and also how to maximize or minimize using calculus. Then the other one is the rate of change, where we say the rate of change of one variable with respect to another variable can be represented by using what is a derivative. So it means when you talk about a derivative, this has to do with a rate of change. For example, if I say, let's say we have a function for volume, or okay, let's say I say dv over dt. This is an example of a rate of change. This is a rate of change. But the rate of change does not have to do with time only. You can also say, let's say dv over dr. So this is the example of the rate of change. Changes in if v is the volume, changes in volume with respect to the radius. If this v, for example, is the velocity, so this is the change in velocity with respect to time. So this is actually regarded as the rate of change. I believe you're well. Right. So this is what you're expected to know under this section of optimization, which is the application of calculus. Right. Moving on to the next slide, guys. Okay, just a minute. Now, in the next slide, it's where we'll be talking about like actually the two-dimensional shapes or two-dimensional object. Right, the 2D shapes, we have shapes such as rectangle. We have shapes such as the square. These are two-dimensional shapes. The circle and also the triangles. All right, it's very important for you to understand the two-dimensional shapes, especially when you are dealing with optimization. All right, under two-dimensional shape, one must familiarize himself or herself with what you call the perimeter and actually the area. And what do you mean by the perimeter? Perimeter is the total distance around the shape. Total distance around the shape is called the perimeter. So if we have a figure, let's say a four-sided figure. I apologize. Let's say you have this figure. And in this figure, you know, one side, let's say it's 8. This is an example, centimeter. And the other side is 5 centimeter. And there it's 8 centimeter. And the other side is 5 centimeter. So if you want to calculate the perimeter of this shape, we know perimeter is just the total distance around the shape. So which means the perimeter, we have to add all the sides around this shape. So it's going to be 8 plus 5 plus 8 plus 5 because we're moving around the shape. And this will give us 8 plus 8 is 16. Then 5 plus 5 is 10. And the perimeter of the shape is 26 centimeter, which means this is in units. So that is the perimeter. So now, how do we, like, again, you must familiarize yourself with the area. Area is just the space enclosed by the boundary of a plane. So this space here is actually called the area. This is the area of this shape. Right, now, in terms of the area, I'll take you through the area of all the two-dimensional shape, guys. And it's very important for you to know the areas of all of the two-dimensional shapes. All right, then now, starting with the rectangle, we see that like in a rectangle has two sides that are opposite to each other and also equal. And we know in a rectangle, there's one side that is always the longest, and we call that the length. So we have the length, and the other side is called the width, or we can call it the breadth. So it's either we use the width as W, the breadth as B. And now a rectangle, it's a 2D object with the perimeter, symbol P, and with the area. And how do we determine the perimeter of the rectangle? We add all the sides. Remember, you do not have to always think about the formula. You must know the application. So now in a rectangle, the perimeter is actually total distance around the shape. So we're going to add the length plus the width or the breadth plus the length or the breadth, which means you're going to have 2 length plus 2 breadth or 2 width. So this is the formula for determining the perimeter of a rectangle. And you must know that it's not always that we'll be using this formula as 2L plus 2W or 2B. It depends with our scenario. It depends with our scenario. Right, again, the formula for calculating the area of a rectangle. With the rectangle, it means what we do, we take one side and we multiply by the other side to get this area here. So it means that the area of this, the formula for calculating the area of a rectangle, its length multiplied by the breadth or the width. Like what I've done earlier. Remember, I said if we have this shape where from this side it's 8 centimeter and the other side it's 5 centimeter. Obviously, this is the rectangle. And how do you calculate the area of this rectangle? You just take one side. Here is the longest side multiplied by the other. So which will just be length multiplied by breadth, which will be 8 by 5, and this will give us 40 centimeters squared. So the area, it is in units squared, unlike a perimeter, which is just in units. Right. Then now I believe you are following. It's very important for you to know the area of a rectangle. Now, moving on, we need to also familiarize yourself with a square and how to determine the area of a square. Obviously, if you know how to determine the area of a rectangle, it will be easy for you to understand how to determine the area and the perimeter of a rectangle. Let me say of a square. Moving on, we talk about a square. And what do you know about a square? A square is just a four-sided figure with all sides equal. So if all the sides are equal in a four-sided figure, then this is actually with an angle of 90 degrees, then this is actually a square. So we know in a square, since all the sides are equal, we no longer have the length and the width. So we just call them the sides. So it's just side, 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 and side. And how do we determine the perimeter? Remember, I said the perimeter is the total distance around the shape. So what we're going to do, we're going to add all the sides to get the perimeter. So it will be side plus another side plus side, which is the same as 4 multiplied by side, which is just 4s, the same as 4s. Then how do we calculate the area? The area, remember I said with a four-sided figure, you take one side and you multiply by the other side. So it's just side multiplied by side, which is the same as side squared in terms of exponents. So this is the formula for calculating the perimeter and the area of a square. I believe you're following. Then moving on to the next slide, we're going to talk about a circle. We're going to talk about a circle. All right. In a circle, we know most of the circle must have the center. And since a circle has the center, if we draw a line that moves from the center of the circle to the circumference, it's called the radius. Then now, what does this mean? It means that if we want to know the perimeter of the circle and its area, then we have to use these two formulas. But in a circle, the perimeter of a circle is regarded as the circumference. So we call it the circumference. It is the circumference. Perimeter of a circle is called the circumference. Total distance around the shape. Then how do we determine the area of a circle? To calculate the area of the circle, we use pi r squared. It's pi multiplied by the square of the radius. So this is the formula for calculating the area of a circle. Ladies and gentlemen, if you want to enjoy optimization, you need to familiarize yourself with the area of a rectangle and its perimeter, the area of a square, the area of a circle, particularly a rectangle and a circle. These are very important, guys. Then you know pi is 22/7, then the r is the radius. And in some instances, you must also familiarize yourself also with the diameter. Because remember, a diameter, it's a line that is joining 2 points in a circle, but by passing through the center. And we know diameter is equals to 2 radius. So sometimes they can give a diameter instead of a radius. And in order to determine the area, we use pi r squared. So it means you have to divide the diameter by 2. So this is the formula for calculating the area of a circle. Then how about the formula calculating the perimeter of the circle, which is called the circumference? Circumference of the circle is determined by using 2 pi r. So this is the formula for calculating the circumference of a circle. And how can you actually remember this formula of determining the circumference of a circle? To remember this formula of 2 pi r, what you're going to do is, since you know how to differentiate, you can differentiate the area, which is actually, this is rate of change actually. You can differentiate the area with respect to r. So this is rate of change. If you differentiate, this is actually the rate of change. The rate of change of an area of A with respect to a radius. So if we differentiate this area looking with respect to radius, this will give us, you know how to differentiate, I believe you know how to differentiate. This will give us 2 pi r to minus 1, and this will give us 2 pi r. So you see that by knowing the area of a circle to get its formula of circumference is straightforward. You just find the rate of change of the area with respect to radius, then it will give you the circumference of a circle. And I believe you are following, guys. I believe you are following. So it's very important for you to know this. Okay, then moving on. Okay, let me just try to erase this. Okay. I believe you guys, you're following. You're following. Right. Kindly don't forget to like and subscribe, guys. Thank you very much. Okay, right. Then let's move on to the next slide. In this next slide, we have a triangle. Right. In a triangle, we know in most of the triangle, if it's a right angle triangle, it must have the base. And since it has the base, it means that other part will be the height, because they should be perpendicular to each other. So how do we calculate the area of the base? To calculate the area of the base, we just say it's half multiplied by base and multiplied by the height. I apologize, not by half. So it's half base times height. So this is the formula for calculating the area of a triangle if it's a right angle triangle. So if you know the base and the height, then you can be able to calculate the area of a triangle. I believe you are following. And how do we actually remember this? Like, let's say you have a four-sided figure. And in a four-sided figure, let's say you divide here, let's say you divide this part here. Okay, how can I do this? Yeah, let's say we divide here. We divided this part here. You see that this part like actually has two triangles. So what we're going to do is, if we know, for example, okay, 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 let me say, we know this is a right angle. Let's say here we have, it is a right angle here, and there it's a right angle. If we know, for example, if we know from here to here, it's 10, it's just an example, and there it's 5. And also, this one is going to be 5, it's going to be 10. So if the area, let's say the area from me, like wanted to know the area of the whole shape, the area of the whole shape would be 10 multiplied by 5, which gives us 50 centimeters squared. So it means if you want to calculate the area of a rectangle. But what if we wanted to know the area of one piece? You see that this shape has actually two pieces, so it means just say half of the area of a what? Of a rectangle. So you see that half of 50 will just become 25. Which is just the same as we say, because this is a right angle triangle. And what is the area of a triangle? It's half multiplied by base multiplied by height. So the base becomes 10 and the height becomes 5. So half of 10 is 5. 5 by 5, it gives us 25. Which means to determine if we say this is the base and this is the height, this is an example of this shape. So it means what you can do, you can just say to calculate the area of one piece, it's half of this base and of the height. So the formula for determining the area of a triangle is half base multiplied by height. Then again, you need to also know how to determine the perimeter of a shape of a triangle. And remember, what did I say about the perimeter? Perimeter is just the total distance around the shape. So if we say from here, let's say here is the B, and there is the A, and there is the C. So to calculate the perimeter, sorry, apologies, perimeter is not the circumference. The perimeter, we add all the sides of this shape. So it's going to be A plus B plus C. So this is the perimeter of a triangle, total distance around the shape. And guys, if you understand how to determine the perimeter and the area of a two-dimensional shape, especially when dealing with a rectangle, when dealing with a circle, then you are good to go. All right, now I'm going to take you through the three-dimensional shapes. Under three-dimensional shape, we're going to talk about a rectangular prism. Then after rectangular prism, I'll take you through the cylinders. After the cylinders, then I'll take you through the cube and the right circular cone. And also this part of second derivative, I think we'll address it later. I'll just take you through the problems that are in 2 dimension and also the problems that are in 3 dimension. Right. Without wasting time, let's deep dive into our session. All right. Then the first one under the 3-dimensional shapes. In a 3-dimensional shape, most 3-dimensional shape usually have 3 dimensions, particularly the ones that has the height. So these are regarded as 3-dimensional shape. So objects that are 3-dimensional must be able to determine its surface areas, which we call it the total area actually, total surface area, which is also fine. Then again, we have to also be able to determine the volume of those objects. Right. In a rectangular prism, we call this a rectangular prism. Rectangular prism is just a box or a container that is made up of a container that is made up of rectangles. So if we use rectangles to construct a box or a container, then that is called a rectangular prism. It's made up of rectangles, so it's called a rectangular prism. Right, you can see that when we have a rectangular prism, since this is made up of a rectangle, one must be able to familiarize himself or herself of the area of a rectangle. Remember, what did we say about the area of a rectangle? To determine the area of a rectangle, since it has length and width or breadth, we just take one side and multiply by the other, which means the area, its length, multiplied by breadth. Right, then which means that here, since we are talking about 3D shapes, so in a 3-dimensional object, we need to be able to know how to determine the surface area and the volume of the shape. Right. If you look on this diagram, we have the length. Actually, most of the diagram must have, most of the prisms or the three-dimensional shapes must have something called a base of the shape. Right. If we say this is the base, this part here underneath is the base, it means the vertical lines always has to be the height, because when in most of the cases when there is a base, the base must be at right angle with the height. Okay, so now if we say the bottom part is our base, then it means the vertical line will always be the height. So now in this rectangular prism, we either use width or the breadth. There's no problem, we can use them interchangeably. So then, since we are dealing with the prism, the volume of any prism, determine the volume of any prism, you must always take the area of a base, you multiply that with the height. The area of the base, you multiply that with the height. Remember, I said in a three-dimensional shape, the base must always be at a right angle with the height. If this is the base, this has to be the height. I believe you are following. So to determine the area, the volume of any prism, I apologize, to determine the volume of any prism, we have to take the area of a base, we multiply by the height. So it's base, it's area of the base multiplied by the height. Now, I'm going to start with the total area. We're going to talk about how to actually determine the surface area or the total area of a prism. Ladies and gentlemen, this is one of the easiest here. To determine the total area, we want to know what is the area that is enclosed by, like the area of this box or the total area of this box. If you look at this box, if we assume that is closed in all the sides, it's closed, then this container will have will have actually six areas, because it's this one and the other one, that other side. Then we'll have this other one and the other one on the other side, the one at the top and the one at the bottom. So you're gonna have, we have to calculate the area of this figure. So to calculate the area, remember I said, since this is a rectangle, even if you forgot the formula, you take one side, then you multiply by the other. So by looking at this, what we can do, if we have a four-sided figure, this will be the length, this will be the breadth or the width, and the other part will be the height. So what we can do is we can start with the base, but this is not a must. And so, okay, in a base, we have the length and we have the breadth or the width. And how do we calculate the area of this base? Remember, I said to calculate the area, we just take one side multiplied by the other if it's a four-sided figure. So it means the area of this will be length multiplied by breadth, which is just LB. But since the base, the area of the base is the same as the one at the top, so it means we're going to add them both. So this will be 2 length and breadth. Then already we have covered the bottom and the top. Then the other part is from here to here, this is the breadth, and this is the height, the vertical one. And what will be the area? We take one side to multiply by the other. So B multiplied by H, this will give us BH. And since it's 2 of them, this will be 2 breadth and height. Then the last one will be the L multiplied by the H. This is still the H. This is still the height. So it will be LH, and it's 2 of them. Guys, you do not have to cram the formula. You just know, you need to know how it is applied. Because sometimes in the exam, they can say, this box is opened at the top. So it means you no longer have 2 length and breadth. you only have one. So it means you're going to use one length and breadth. So it's very important for you to know the formula, actually, like to understand how to determine the surface area and the volume of a two-dimensional shape. So here I want to talk about how to calculate the volume of a rectangular prism. Right, since this is a rectangular prism, which is a box or a container that is made up of rectangles, to determine the volume of a rectangular prism, the formula for calculating the volume of any prism, what to do, we take the area of a base and we multiply by the height. And when you look here, what is our base? Our base, it is in the form of a rectangle. It's a rectangle with the length and the breadth or the width. So it means to determine the area of a rectangular prism, we need to calculate the area of a rectangle because it's our base there, and we multiply by the height. And what is the area of the rectangle? We take one side by the other. So it's length by breadth by height. So this is the formula for calculating the volume of a prism, ladies and gentlemen. I believe you are following. Then we're gonna move on to a cube, if I'm not mistaken, or a cylinder. Gonna move on to a cube or a cylinder. All right, moving on to the next slide, then we have a cylinder. Right. A cylinder is just like, for example, we can just give an example of a cylinder. When you have the bucket that you use at home to fetch water. Right. That is an example of a cylinder. You realize that on a cylinder has actually three shapes. If we cut the top part of the cylinder has a circle. If we are calling this a base, remember, if this is a base, it means the vertical part will always be the height. It must be at right angle to each other. Right, then now, with this, since we know that on a cylinder, there is a circle. So if we can cut this top part here, this gives us a circle. And also we can cut the base or the bottom part. It also give us a circle. So you realize that in a cylinder, if we can cut the top part and remove the bottom part, these are the circles. So we're gonna remain with something like this with no circle in it. So what we're gonna do, since this is the height, remember, if we cut, like let's say we cut this part here and we unfold it. If we unfold the part, it means the shape will still be like we're gonna have something like this. Whereby if from here to here it will be the height. And this part here, it's actually called the circumference. Why is it the circumference? Because even if we have removed a circle here, the distance from here up until this part here, up until here, this is actually the circumference. You see total distance around. Even if we cut it, it will still have the same distance. So this is actually the circumference of the circle, if this is the height. And we know the circumference of the circle, it's 2 pi r. And how do we remember this? By knowing the area of the circle. We know area of the circle is pi r squared. The area of the circle is pi r squared. Which means if we determine or you differentiate this area with respect to r, it will give us the 2 pi r, which is what I'm talking about here. It's the circumference. So it means that on a cylinder has two circles and a rectangle. And guys, it's very important in the exam to read the question and understand, because sometimes they'll say that this container or a cylinder has no lid. And what does it mean? If it has no lid, means one circle is being removed. It means you no longer have two circles. So you must understand. You must actually understand. Then on a cylinder has what you call the total surface area. And how do we determine the surface area of this? It means we have to add the area of the two circles and the area of a rectangle, which is 2 times the area of a circle plus the area of a rectangle. So how do we determine, like we know the area of the circle is pi r squared. So it means pi r squared plus pi r squared. This will give us 2 pi r squared. So this is the area of circles. Then how do you determine the area of the rectangle? Remember I've told you that when we determine the area of a rectangle, we take one side and multiply by the other. So we can regard this length multiplied by breadth. So here we're gonna take 2 pi r, multiply with the h. So this will give us 2 pi rh. So this is the formula for determining the total surface area of a cylinder. So from here, we can take a common factor if you want to rearrange. The common factor here is 2 pi r, and we're going to remain with r plus the h. So this is the formula for determining the surface area of a cylinder. Very important, ladies and gentlemen. Do not cram the formula. You have to understand what you are actually doing. And read the question, because sometimes they say you are given this cylinder and the cylinder has no lid, which means you're not going to use 2 pi r squared instead of, yes, so you're going to use pi r squared because one circle is being removed. So it's very important to know that. Right, moving on, let's continue. So I strongly believe you understand what we are doing here. Remember, as I said, if you know the areas of a 2-dimension object, then it will be easier to understand the areas, or so surface area of a 3-dimensional shape. Oh, by the way, we're not done. How about to determine the volume of a cylinder? Remember, cylinder is just a prism. To determine the volume of any prism, remember, what did I say? I said to determine the area of any prism, the volume of a prism, we take the area of a base and we multiply by the height. And now, ladies and gentlemen, what is our base here? Our base is a circle. So it means we're going to take the area of a circle and we multiply that by height. And what is the area of a circle? Area of the circle is pi r squared multiplied by the h. So this is the formula for determining the volume of a cylinder. So it's pi r squared h. So it's the formula for the volume of a cylinder. Okay, right. Without wasting time, guys, if you feel like I'm in a hurry or I'm rushing my lesson, just pause the video and go through it on your own. Right. Then now we move on. Yes, this is pi r squared h. This is the full formula for determining the volume of a cylinder. It's very important to understand, not cram, understand what you're doing. All right, then the other one is the issue of a cube. Remember, what is a cube? A cube is just a box or a container that is made up of squares. So it means if we form a box or we form a container using squares, then that shape become a cube, box or a container that is made up of squares. Now we're using squares. We're not using a rectangle. So it means in a cube, all the sides are equal. And since it's a 3-dimensional shape, we're supposed to have the length, the breadth, and the height. So we no longer have length, breadth, and height because all the sides are equal. So we just call them the sides, or you can call them it's D, 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 side, side, side. And how do we calculate the area or the total area of this cube if it's closed? Remember, if we know one area of this cube, then we already know the area of the other side, the area, other parts. So the area is one side multiplied by the other. So if you say this is the D and there is the D, so what will be the area? The area is D times D. This gives us D squared. So this one has an area of D squared. This one also has an area of D squared. Even the base has the area of D squared. Even that other part has an area of D squared, then the area of D squared. Then we add all this area, it will be 6D squared. Because it's D squared plus 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 D squared, then all of them are 6D squared. Then now, how do we calculate the volume? Same applies. Volume of a prism is the area of the base multiplied by the height. But here the base will be D multiplied by D. The height will be the D. And this becomes D cubic. Remember, I told you, you do not have to cram the formula. You need to know what you are actually doing. Very important. Very, 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 very important, ladies and gentlemen. It's very important. Okay, I'll give one scenario. Okay, let's say you are given, it does not matter. Okay, fine. Let me just do one example without having to master the formula. You have to know what you're actually doing. For example, let's say we are given, a box. It's just a box here. And this box has the following dimension. So this is our box with the following dimensions. So the box, let's say from here to here, it's 8 centimeter. There it's 5 centimeter. And there it's 3 centimeter. And we are, let's assume this box is closed. And we are asked to determine the volume of this box and its surface area or total surface. Guys, that's why I said you do not have to cram the formula. You have to understand what you are doing. Right, from here, we can determine the total surface area by doing like this. What we can do, you can see, okay, even if, okay, we know this is the length, this is the breadth, and this is the height. But what we can do, we can say, okay, fine. From here to here, we have 8. And the vertical part is 5. So it means we can calculate the area of this part here, which is 8 multiplied by 5. So 8 multiplied by 5, this gives us 40 centimeters squared. It means this has an area of 40. If it means even that other part, that side has an area of 40. So it means we're going to have 40 plus 40, which will just give us 80 already. Plus, you see, by knowing, okay, this is 40 because it's 5, from 8 by 5, it's 40. If you know this area, this side, we already know the area on the other side. So now we can, what we can do, we can, okay, fine, we can look at the base. If this is 8 here, and the breadth, it's 3. So to calculate the area, it's 8 multiplied by 3. 8 times 3 is 24. So we know that if that is the case, if the area of, if the base here has an area of 24, it means even this top part here will also have an area of 24, which means the total area here of the top and the bottom is 48 plus. And then what do we remain with? We remain with this other part, this side. From here, this is the breadth, and the vertical part is the height, which is just 5. So how to calculate the area? It's 3 multiplied by 5, which gives us 15. And by knowing that this has an area of 15, it means even that other part has an area of 15. So already you see that it's 15 plus 15, which just gives us 30. And to add this is the same as, is the same as what we said is 2 length and breadth, which is 2 times 40 plus 2 times 24 plus 2 times 15, which just gives us 30. So 2 times 40, which is 80, plus 48, plus 30. This is a total area of 158 centimeter squared. You see, by knowing what you're doing, then it's easier. Then how about the volume? The volume, it's like we multiply different sides here. So it's length, breadth, and height. So we can say it's 8 multiplied by 3 multiplied by 5. 8 by 3 by 5. So this will give us an area of 120, a volume of 120 centimeter cubic. This is in unit cubic. So I believe you are following, guys. I believe you are following. All right, let's move on without wasting time. Okay, now I'm going to take you through the right circular cone. Right. In a right circular cone, ladies and gentlemen, this is one of the concepts where in the exam, especially in grade 12, if they give you a circular cone, they usually will give you the formula. The formula to determine the total surface area and the volume of that cone. Because particularly for a grade 12 learner, this is actually too complicated if we were to explain the formula. Right, then now, in a cone will have a base here. So this will be the base of the cone, which is actually a circle. And if this is the base, it means the vertical part will be the height, as I said. And since this base is a circle, it means this circle has what you call the radius. And this is the radius. Then we also have this other part from the vertex up until here. This is called a slant height. This is called a slant height in a cone. And how do we determine this slant height? If you realize that this shape is actually a right angle triangle. And in the right angle triangle, we can use theorem of Pythagoras. So it means this is what you can use to determine the slant height. So the slant height, the R here will be our slant height, the X will be the radius, and the Y will be the height. So it means if we take L squared will be equal to the R squared plus the height, the H squared. So we can determine the slant height by making a root sign. So the L is the root of the R squared plus the H squared. So if we know the radius and the height, then we can determine the slant height. So how do we calculate the total area of a cylinder? I'm saying a cone. In a cone, one part of the cone, if we cut one part of, or the base of the cone, this is a circle. Then what we're going to remain with, we're going to remain with something like this. Obvious. So if we cut one part, then we're going to have something like this. We're going to have something like this, which is actually in the shape of a sector. So you see that to determine the area of a cone, we take the area of a circle and we multiply by, okay, this is our slant height. We multiply by the area of this sector actually. But however, for a grade 12 learner, you don't have to master this formula. If they give you a cone, they will give you the formulas for you to determine the surface area. Because, okay, fine, we know the area of a circle is pi r squared. We know this one. The area of the circle is pi r squared. So to calculate the area of this part, actually, it's like we have to actually take the arc length. We have to calculate the arc length. So what we do, the formula, it's just 2 pi RL, then we divide by the circumference of the circle, which is 2 pi r, and we multiply by the area of the circle. You don't have to master you don't have to know these guys. They'll give you the formula. I just want to show how they got this. And we calculate, we multiply by the area of a full circle. So you realize that here, the 2 pi and the 2 pi, or actually 2 pi r and the 2 like 2 pi r. No. Oh, this is pi. Yes, it's 2 pi times the L, not yes, 2 pi r. Yes, the arc length of the circumference. It's 2 pi times the L. Then done now. So it's gonna be 2 pi times L divided by 2 pi r multiplied by pi r squared. So the 2 pi and the 2 pi will divide, and the r and the r will divide. Then we're gonna remain with pi rl. So this is how they got this. But don't stress about yourself about this, guys. Don't even stress yourself. If they give you a cone, usually they will give you the formula. Right. So total surface area of a cone is pi r squared plus the 2rl. What is the L represent here? I apologize, guys. Here I use the bigger L. It's still the same. Then the L here, it's our slant height. This is the slant height. And to calculate the slant height, we use this theorem of Pythagoras. Then now, how do we calculate the volume of this cone? Remember what did I say? The volume of the cone here, like of any prism, but since this one is just a cone comes from like a cylinder. If we reconstruct this, then in a cylinder, then we can have a cone. So now, what does it mean? It means to determine the volume of a cone is actually, the volume of a cone, it's 1/3 of the volume of a cylinder. So if we know the volume of a cylinder, remember volume of a cylinder, it's given as pi r squared, h. So if we determine 1/3 of the volume of the cylinder, it will give us the volume of a cone. So if we multiply this by 1/3, 1/3, then 1/3 times the volume of the cylinder, it's actually it gives us the volume of a cone, ladies and gentlemen. So I believe you are following. All right. Then remember, for you, like in optimization, you need to actually understand the shapes, the shapes of object. And if you understand the shapes of an object, it will be easier for you to answer the questions that are relating to optimization. And this one is one of the easiest questions, guys. Right, then now we continue. Okay, in terms of the second derivative, guys, I'll talk about this after. I want us to move on to the application. Right, before moving on to the application, guys, I want to address something very important, especially when we are dealing with optimization. Look, guys, it's very, very important to actually know what you are doing. Remember, the objective of learning differential calculus is to determine the derivative, or to determine, or to actually estimate the gradient at a point. How do we actually determine the gradient at a point? To determine the gradient at a point, we could actually use a derivative. Okay, apologize. That's why from the first principle where we said f prime x is the limit when h approaches 0 of f of x plus h minus f of x over h. This is just a formula to determine the gradient at a point. Remember, how did we get this? We used we estimated the gradient at a point by using the gradient of a secant. So it means that in calculus, once you say f prime x, or you say dy over dx, you are actually talking about a gradient function. You are calculating, you're actually determining a gradient function at a point. And what does this mean? It means that if you have, let's say, you have a line, we know that if, let's say, we have a function or a curve, we know that on a curve where the curve is actually increasing, if the curve is increasing, it means its gradient actually is bigger than 0. It's positive. But if the line is not increasing or decreasing, we say the line is actually constant. And where the line is not increasing or decreasing, it's actually, we say its gradient, it's always 0. Same applies if the line that is decreasing, it means its gradient is less than 0, it's negative. Then the other part is not increasing or decreasing, then its gradient, it's 0. Then this side, it's increasing, it means its gradient is positive. So what does it mean? It means that when you talk about gradient in derivative, we're talking about, in calculus, talking about f prime x. So if f prime x is bigger than 0, it means that that line is actually increasing. And if the gradient is 0, it means that that line is actually stationary or constant. But if the line, the gradient is negative, then we know that that line is actually decreasing. It's a gradient function. So which means that you must realize that from this curve, there's some part where you find that one becomes the local maximum, or you can just regard it the maximum, and the other one is the minimum. You see that at the maximum or the minimum points of any curve, the gradient is always 0. And this is what we'll be using when we are going to the application of calculus, to say whether maximum points, the maximum or the minimum, always the derivative of that function should always be 0. Why? Because at the maximum or at the minimum, the graph is the gradient of that function. It's 0. The graph is not increasing and the graph is not decreasing. So it's very important for you to know this. Very, very, very important, guys. I believe you are following. Right. Let us go through the examples, the applications of calculus. Yeah, I'll just take you through a couple of examples in order to actually use whatever I said earlier then in solving problems. Guys, this is one of the easiest topic in calculus, only when you understand what you are doing. Right, then now, okay, let me take you through. Okay, the issue of the point of inflections and the concavity will address that in other sessions. But now I want to take you through the issue of height and distance problem. Right. Here we have an example. It says a rectangular area is to be enclosed on 3 sides by the fence and the existing hedge which forms the 4th side. What does this mean? It means they want to fence this rectangular shape. And by fencing this, they want to fence on only 3 sides of this rectangular shape, because this other side is just a hedge. It means they don't have to fence this part. Then a 100-meter fence, a 100-meter fence, it's available to construct this rectangle. So what does it mean? This 100-meter fence, actually, it is the perimeter. We are given the perimeter of the fence. It's 100 meter. So it means the available fence that they have, it has a total distance of 100. So they have to use it to enclose this rectangle, but not on all sides, but only on 3 sides. So it means this side, it's not included. And now, ladies and gentlemen, since here we are given a 100-meter fence, which is available to construct this rectangle, so we know we are actually given a perimeter. We're given a perimeter of this rectangle. It's not the area, it's the perimeter. Because they have a 100-meter fence, you have to use it to construct this area. And the first question says, show that a rectangular area, the rectangular area is given by this. Okay, what we can do is yes, fine. Let's just let me use this part beside. I'll just try to erase this part here. So what does it mean here? It means that we have a four-sided figure. We are given a four-sided figure. And within this four-sided figure, one part of the figure is just a hedge. It means there's no need for, we're not going to construct like a fence. We're not going to put a fence here. It's just a hedge. So we have to construct, we have to put a fence here and the other part and the other part. But we're given this dimension. But if you look at this, guys, this is a rectangle, ladies and gentlemen. And this rectangle has the longest side, which is, yes, is the length, and there is the breadth or the width. And guys, how do we determine the area of a rectangle? I think I've explained this several times. The area of the rectangle, we take one side, we multiply by the other. So in terms, we're going to say it's length multiplied by breadth. Even if you do not write this, but by knowing what you are doing. So the length there is the y, and the breadth is the x. So this becomes xy. So you look at our area. The area, it is in terms of both x and y. But according to our question, they say we must show that the area is 100x minus 2x. You see that it is in terms of x only. It's not in terms of y. So it means we're going to go back to our experience. Okay, so it means to determine the area of this, we need to replace this y. We need to write y to be in terms of x. And the best way to do that is to use that information provided. Right, now we're given this perimeter of 100. So we know, what is perimeter, guys? Perimeter is the total distance around the shape. But now here, we're not gonna add the part of the hedge. So it means our perimeter here will be the x plus the y plus the x. Distance around the shape, which gives us 2x plus y. So we know the perimeter. The perimeter is 100. So 100 equals to 2x plus y. Then we're going to make y the subject of the formula. So the y will be 100 minus 2x. So in that case, then we're going to substitute the y by 100 minus 2x. Then we remove the brackets. Let's remove the brackets. X times 100, this gives us 100x. Then this gives us 2x squared. So now we have proved the area. But the area of this rectangular shape is actually pi, or 100x minus 2x squared. Guys, I apologize for talking about pi. So we were able to determine the area. So it's very important for you to understand these guys. Okay, let's move on to the next question. Okay, let me erase this. Okay. Then now, the next question says, find the dimensions of the rectangle. Find the dimension of the rectangle that will maximize the area. We want to know the dimensions that will maximize the area. In other words, we want to maximize the area. We do not want the maximum area, but we want the dimensions that will maximize the area. And now we're going to say, okay, fine. In the shape provided there, we only have this. Remember, we said this part is the edge. So we have the x and we have the y. Remember, this x and the y is actually our dimensions. We want to know what would be the x, the value of x, and what is the value of y, which will maximize the area. Remember, this is a calculus, guys. Right, what are we going to do here? We want to maximize the area. So we have the area as a function of x. So the area is 100x minus 2x squared, if I'm not mistaken. Let me confirm. Yes, 100x minus 2x squared. So we want to maximize area. Remember, under calculus, whether they're talking about maximum or the minimum, at the maximum or the minimum, the gradient is 0. And since the gradient is 0 under calculus, a gradient function is regarded as f prime x, a derivative. The derivative should be 0. So it means you're going to say for maximum area, or the derivative of an area with respect to its function, like variable x, should always be equals to 0. Why? Because at the maximum or at the minimum, the gradient is always 0. So this is what you must always do. So what does it mean? It means we have to differentiate our function with respect to x. So this will be 100 minus our derivative. This will be 2 by 2, which is 4x equals to 0. Then we solve for x. So 100 equals to 4x. Then we divide by x. So 100 divided by 4 will give us 25. So what does it mean? It means that the width of this rectangle should be 25 centimeter. Oh, did they give us the unit? Okay, meter, okay, it's in meter. So it means the x should be 25. And remember, I want to note the dimensions. So the x should be 25 meter. And how about the y? And how do we actually determine this y? To determine the y, because this function is not a function of y, it's a function of x. We want to maximize the area. So we're going to say, we know that y equals to 100 minus 2x. So you can say y equals to 100 minus 2 times 25, if I'm not mistaken. How do you get this? Remember, we got it from where we said p equals to 2x plus y. The p, it's 100. If we transpose it this side, then this is our y. So you realize that will be 100 minus 2 into 25, then this will give us a dimension of 50 meter. So it means in terms of dimensions, the x or the length should be 50 meter and the breadth should be 25 meter in order to get the maximum volume. So that is what the question was looking for. Right, then now moving on. Okay, guys, let me erase this. Okay. I believe you are following, guys. I believe you are following. Okay. Then now we move on to the next question. Right. The next question says, hence determine the maximum area. Hence determine the maximum area. We now want to determine the maximum area. And we can determine the maximum area because we know the dimensions that will maximize the area. We know that to maximize the area, x should be 25 meter and the y should be 50 meter. We got that. So here it should be 25 meter and there should be 50 meter. And now we want to determine that area. So what we can do, we can either take the area, the area of this shape, in terms of x, we say the area is 100x minus 2x squared. Then when there is x, we substitute by the x by 25. I apologize. And this will give us an area of 100 into 25 minus 2 into 25 squared. Then the area becomes 1,250 centimeters squared. So this is the area. Another way we'll say the area, it's length multiplied by breadth. Then we have 50 multiplied by 25. Still 50 multiplied by 25 will still give us an area of 1,250 meters squared. I apologize, guys. Don't know why am I using centimeter, because they said it's a meter. So this is the area of the shape. Then again, they said the cost of fencing is 20 rand per meter. The cost of fencing is 20 rand per meter. And the rectangular area must be 200 meters squared. So then what is the question? What are the dimensions such that the cost will be minimal? Here we want to minimize the cost. We do not want to minimize the area. We want to minimize the cost. So let's write the information here. We do not want to minimize the area. We want to minimize the cost. All right. Then to do that, let's draw our shape and try to solve the question. So we're going to say, okay, fine. Since we have our, like the shape of where we need to put the fence. Remember, we said this side is the hedge. We explained that. So this is the x meter, this is the x meter. This is the y meter, it's in meter. This is the x meter. It is where we need to put the fence actually. So now, here we want to minimize the cost. And according to the statement, they said, if the area of this figure already, if the area of the figure is 200 meters squared, so we are already given the area. So we don't want to minimize the area is 200. We want to minimize costs. And since we have to minimize cost, means we must have a cost function, must have the equation for a cost in order to minimize cost, because we do not minimize the area, we minimize the cost. And we are told that the cost of fencing is 20 rand per meter. 20 rand per meter. Per 1 meter is 20 rand. And now, guys, it's very important to understand. So we know that 1 meter of a fence will actually cost us 20 rand. Okay, guys, just a minute. I'll be back. I need to attend to something. Just a minute, guys. Okay, welcome back, guys. Post the video. Okay, now as I was saying, they're saying the cost of fencing is 20 rand per meter. So now it means you're gonna say, okay, 1 meter will cost us 20 rand to construct here. Now, how are we going to do this? We're going to say, okay, fine. From here up until here, From here to here it's x. From there to there it's x. It's y. From there to there is x meter. We do not know the actual meter. So we want to minimize the cost. We want to know the dimensions that will minimize the cost. So what we're going to do, we're going to say, okay, if 1 meter cost us 20 rand, how about the x meter from here to here? Obviously, the x meter will cost us 20x because we do not know the dimension. I hope you understand. Remember, if 1 meter is costing us 20 rand, how about 2 meter? It will cost us 40 rand, right? So how about x meter? It will cost us 20x because the 40 rand was 20 times 2. I hope you are following there. So it means that to construct this site here, to construct this site here, it will just cost us 20x. This is the cost. And to construct from here to here, it will cost us 20y. And here it will cost us 20x. I hope you are following. Because if from here to here was 25 meters, just an example. Obviously, we know 1 meter cost us 20 rand, so it will be 25 times 20, which is just 500. But now, since we do not know the dimension, we'll just say it will cost us x. I'm saying 20x rands. So it means we're going to come up with the cost function to say, okay, the cost function, it will be C, let's regard it as C, cost function equals to 20x plus 20y plus another 20x. I believe you are following. So the cost function now will be 40x plus 20y. Now, our cost function, it's a function of x and it's a function of y. And since here we want to optimize, it means we need to change one variable to be in terms of the other so that we remain with one variable. And how are we going to do that? We are given the area. They told us the area of the shape is 200. And since this is a rectangle, we're going to say, okay, the area is one side multiplied by the other. And since the area is 200, what is the length? The length is y, the breadth is x. So to multiply that, it will give us xy. So we have to change y here and remain with x. So we're going to divide everything by x here, then the y will be 200 over x. So it means in our cost function there, where there is y, we're going to substitute the y by 200 over x. So then now, we can now simplify our expression as 40x plus 20 times 200, this will give us 4,000. So we're going to have 4,000 divided by x. But you know in calculus, since we are going to do the derivative here, guys, we cannot differentiate a function with respect to a parameter that is in the denominator in grade 12. But when you go to university, you can still make a derivative of that. For example, if you have y equals to 4 over x to the power of 3, you cannot find dy over dx with respect to the x which is at the denominator. We need to transpose, we need to move this x to the numerator, and by playing around with the exponent. If it's plus, when it goes up, it becomes negative. That is how you need to know. So it means this will become y equals to 4x raised to the power minus 3. We can even take it down. So it's just playing about, like we just use we are playing around the powers actually. So it means to do this, if we are going to use calculus, we need to simplify and say this becomes 40x plus 4,000 multiplied by x to the power negative 1, because it is a positive exponent. We take it up, it will become negative. So this is our cost function. So now we have the cost function. We want to minimize the cost. We want to minimize the cost. I believe you are following. Then now we're going to do this because, okay, fine. In calculus, we know whether we are minimizing or whether we are maximizing. For minimum or for maximum, the gradient will always be equal to 0. We're talking about derivative. Maximum or minimum, the derivative should be 0. I think I spoke about that. So what we're going to do, we're going to say, okay, fine. Because this C here, it's a function of x, we have to differentiate the cost function because we want to minimize the cost. So I'm going to, okay, let's do this. Okay, I believe you are following, yeah? Okay, so I'm gonna say, okay, for minimum, for the minimum cost, to get the minimum cost, to minimize the cost, the derivative of the cost with respect to the variable of interval, which is x, should always be equal to 0. Minimum or maximum, we always do this. So we're going to differentiate the cost with respect to x here. Then we know, I believe you know how to differentiate. This becomes 40. Then this one will bring it down, will reduce by 1. This will become minus 4,000. X to the power minus 1, which is minus 2, equals to 0. We want to solve for x. So this will give us 40 equals to 4,000 x to the power minus 2. Then 40 equals, then we transpose this. We have to to change the exponent not to be negative. So it means we have to bring it down now, the denominator. So we're going to have something like this. It's the same thing. So this is over 1, ladies and gentlemen. Then we can now cross multiply. So we're going to have 40x squared equals to 4,000. We divide everything by 40. So this will give us x squared equals to 100. And since here the dimension, the x is positive because it's the length, so we cannot have a negative length. So then now we're going to put the root sign both sides. We're not going to allow plus or minus. So which means that the value of x should be 10 meters. If we want to minimize the area, the x should be 10. And remember, the question says determine the dimensions. Determine the dimensions that will minimize the cost. We want to minimize the cost. So it means the x should be 10. And since we want the dimension, we want both x and y. We want both x and y, the x and the y. So how are we going to get the y? Remember, we determined we expressed the function of y in terms of x by saying y equals to 200 divided by x. I think we used it here. So it means where there is x, we're going to put 10. Obvious. The y should be 20 meters. So it means if this is 10 meters, then this one should be 20. 10 times 20 gives us 200. So to minimize the area, I'm saying to minimize the cost, the fence should have a breadth of 10 meters and a length of 20. So the length should be 20 meters and the breadth should be 10 meters in order for us to minimize the cost. I believe you are feeling. Guys, you need to know this. These things are very important. Calculus, maximum or minimum, the derivative should always be equals to 0 at that point in that function. I believe you are following. All right, we can move on to the next question, but due to time frame, I will try to be fast in the next questions, and some of them I can lead you to go and do them on your own. I will guide you on like how we are going to solve the question. Remember, maximum or minimum, always the gradient should be 0. The derivative of a function should be 0. We have to differentiate that function. We equate it to 0. Don't forget that. It's very important. Maximum or minimum. It does not matter what you're minimizing or you're maximizing. All right, then now we are done with because here we want to minimize the cost. We don't want the cost, we want to minimize the cost. And if we wanted to the cost, whether in the cost function, we're going to substitute by the x, which is 10, then it will give us the cost, the cost, how much it will cost us. And we can do that because like remember, it's not part of the question actually, I'm just adding. So the cost function, remember it was 40x plus, let's say 4,000 over x. So it means when there is x, we can substitute by 10 to actually know what is the cost. How much will it cost us to put the fence there? Okay, so this will be 400. So this will also be 400. So it will actually cost us 800 rands to construct that fence. I believe you guys are following. I believe you're following. I believe you're following, guys. Okay, so this is the minimum actually. It's like it is the minimum cost. Okay, I believe you're following, guys. Let's move on to the next question. Practice makes perfect, guys. Okay, kindly don't forget to subscribe and like and also share with other friends. Right, here is the second one. Here is the second one. Here they're saying a new design for a rectangular table place has been implemented by a company manufacturing dining room items. On the two-width side of a rectangular place mat. So what does this mean? We are given a rectangular sheet, and this rectangular sheet, remember a rectangle has the length and the breadth. So this is our rectangle, which has the length and the breadth or the width. So on the two-width side, the width or the breadth of the rectangular placemat, two wide semicircle are pasted as shown in the diagram below. What does it mean? It means that they had a rectangle. This rectangle has dimension of length and breadth. And within this rectangle, they have to cut out the semicircle, half circle actually. They have to cut out equal half semicircles, I apologize. And cutting out these semicircles means they have to remove this part here, and they must also remove the other part here. So they have to remove semicircles in this rectangle in order to remain with this shaded part here. So they've removed two semicircles like from this rectangle. So then they're saying the remaining area has to be shaded. You see, this is what I'm actually saying, with a multicolored pattern. So the length of the placemat remains 100. It remain fixed as 100. So it means from here to here, it's 100 millimeter. While the width or the breadth of the mat can vary in length. So it means here it's given as the x. So it means this rectangle was actually having the length of 100 and the width or the breadth of x, according to this scenario. So what does this mean, guys? It means that, it means that we had a rectangle. This mat, the mat was having dimensions of, let's say this is the length and this is the breadth. The dimensions of the rectangle, the length is 100 millimeter And the breadth is actually x millimeter. So from these rectangle, they removed half circles. They cut half circle, this side, semicircle, and they also cut the semicircle of equal length. So when they remove this, they remain with this shaded part here. And guys, it's very important for you to understand what actually has happened here. Now, it means that we had a rectangle, and from the rectangle, we removed the semicircles. We removed the semicircle. Two semicircles. Or they removed semicircles. Then they want to remain with this part, this one, the shaded area. Then now, according to the statement here, it says, show that the shaded area is given by this. We want to show that the shaded area is given by this. Obvious, to determine the shaded area, it means we have to take the area of a rectangle and we remove the area of semicircles. And guys, look at this. If we have a circle, and maybe we divide the circle into two parts, you see that the circle will have semicircle, it will be half circles. It's just an example. So which means that if we take half circle and half circle, we actually remove the circle actually. So it means that to determine the area of a shaded, to determine the area of the remaining part there, it will say the area left it will be the area of a rectangle minus the area of a circle. Why area of a circle, guys? Because this is half of a circle and half of a circle. So half plus half combined will give us a full circle. And guys, remember, if this is half of a circle, from here to here, this will actually become a breadth in a rectangle, but in a half circle. In a half circle, from here to here, it's x. And remember, in a half circle, when I have the radius, so it means now we're given a diameter, and we know diameter is equal to 2 radius. So it means if the diameter is x, what will be the radius? The radius would be x over 2. I believe you understand what I said. Because if from here to here is the x, it will be the breadth if we are talking about rectangle, but it will be the diameter in a semicircle. So what is the area of the rectangle? Area of the rectangle is length multiplied by breadth. And what's the area of the circle? It's pi r squared. But they want this to be in terms of x. So what is the length? The length is 100. What is the breadth? The breadth is x. Minus pi. What is the r? Remember here, this was the breadth in terms of rectangle, but in a semicircle, it is now becoming a diameter. From here to its diameter. So the radius is it's from the center to the circumference. So this is the radius. So we want the radius, which will be the half of a diameter. So what is the diameter? Diameter is x. So half of a diameter is just x over 2. So this will be squared, which means this will be 100x minus, then we expand this because this is x over 2 squared This is just x over 2 times. So this will be pi x squared over 4. So this is, we have proved that the area is given by 100x minus 1 over 4 pi x squared, or pi x squared over 4. There's no problem. Pi x squared over 4. So now, so this is pi x squared over 4. So this is the area left. This is the area left. So I believe you are following, guys. It's pi x, 100x minus pi x squared over 4. I believe you guys, you're following. Okay? Then now we can move on to the next question. Remember, the next question is straightforward. Either maximum or minimum, the derivative of that function should be 0. Calculus, application of calculus, guys. Okay? Right. Then the second question says, determine the maximum shaded area possible. What is the maximum shaded area possible? We want to determine the maximum shaded area possible. It means here we want to get the maximum area. Obvious, in order to get the maximum area, we need to know the value of x that will give us that maximum area. So the area we know is 100x minus pi x squared over 4, if I'm not mistaken. So this is the function. Yes. So we're going to say for maximum area, to maximize the area, the derivative of the area with respect to x, because this is a function of x, should always be 0. So it means now we have to differentiate our expression, because the variable that we're differentiating with respect to, it's at the numerator, then we can differentiate. This will become 100 minus 2 pi x reduced by 1 over 4, then equals to 0. Then we can simplify this as 100 minus, then you see the 2 divide, then this becomes 2 pi x over 2 equals to 0. Then we transpose the pi x over 2 to the right-hand side. So it's 100 equals to pi x over 2, and that's over 1. Then we cross multiply. We're going to have pi x equals to 200. Then divide them by pi, and divide them by pi. And now remember, we want to know what is the area, not the x. It means here we are determining the value of x that will actually maximize the area. And to do that, we can just say 200 divided by pi. Okay. So 200 divided by pi will be 63.66. So it means in order to get the maximum area, the width should be 63.66 millimeters. But now the question says determine the maximum possible area, not the x. So it means this is not the final answer. So we are going to say we determine the maximum area. Determine the maximum area, we're going to substitute this value of x into the area function. So this will be 100 multiplied by 63.66 minus pi into 63.66 squared over 4. Then this will give us the maximum possible area. So 63.66 minus pi into 63.66 squared over 4. then this will give us an area of 3,183.10 millimeter cubic, because millimeter squared. I apologize, guys. I apologize. No, not a cubic, but it's a squared. Because this is an area. Okay, I believe you are following. I believe you are following. I believe you're following. So, right, the next one, okay, let me erase this. Okay. And please, guys, wherever you don't understand, you just pause the video and just go through all the steps that I'm actually explaining. And if you do not understand, then also you can keep in touch with me. Then I'll be able to address your questions. And then now, okay, let's move on. Let's move on. Then in this one, this is a rectangular box. Yeah, I think with these guys, I will just guide you on what you should do. Then you can be able to answer the question. Same applies with the next one and the next one. Some of them, I'll also create another video to address them, guys, due to time. All right, let us look on this one. This one, it says the rectangular box has the length of 5x. So we're given a box that has the length of 5x. And a breadth, or the width of the box, it's 9 minus 2x. And the height, it's x units. This is units. Then the first question says, show that the volume of the box is given by this. And guys, what we can do is we can just, okay, fine. From the information provided there, we can do this. We can say, okay, fine. We're given a box. This is our box. Okay. Let me construct our box. Okay, this box has a length. Sorry. The length of the box here is 5x. The breadth is 9 minus 2x. 9 minus 2x. So there it's 5x. There it's 9 minus 2x. The height is x. This is what we're given. And we know, guys, that in a rectangular prism, we can actually determine the surface area, and also we can determine the volume. So now, how to determine the volume of any prism? Remember, I said determine the volume of the prism. We actually take the area of the base and we multiply by height. So it means the volume here, it will be length multiplied by breadth multiplied by height. And then now, with this, we can also determine the total surface area of this without having to remember the formula. How to determine the total surface area? I think they did not mention the issue of whether the box, they did not talk about a box being opened here. So we're gonna say, okay, fine. Determine the total area of this shape. We're gonna say, okay, the total surface area of this, we can take one side, we multiply by the other. Let's start with the base. So there's length, there's breadth. So it's length times breadth, but it's because it's two of them, so it will be 2 length and breadth plus. Then here is the length and there is the height. So what is the dimension? It's length multiplied by height. So it's LH. How many are they? 2 of them. So it's 2 length and height. Plus, so we're done with length and breadth, length and height. Then we're going to look at the breadth and the height. So the breadth times the height is BH, which is 2 BH. So we can determine the volume and also the surface area in terms of X and Y. So I want us guys to just get the volume and the surface area, then the rest shall follow. Yes, you see, they want us to determine the total surface area. Actually, they say calculate, sorry, you're supposed to say calculate the total surface area in terms of X. Okay, but it's fine. It's fine. We'll address that. 5x, 9 minus 2x, then the height is the okay. They say to show that the volume of this given by this. So let us do that. So we're going to go back to our expression. Okay, let me try to erase this. So we know that in a rectangular prism, volume is length, breadth, and height. And so it means we're going to substitute by our length, our breadth, and our height to determine the volume. So sorry guys, the volume is, what is the length? Is 5x. What is the breadth? 5x multiplied by, what is the breadth, guys? The breadth it's 9 minus 2x. What is the height? The height is the x. So to simplify this, we can either multiply this with that first. This will give us 5x squared with 9 minus 2x. Then we remove the brackets. Removing the brackets, so this will be 45x squared, and this will be 10x cubic. So this is the formula. Like we have derived the volume equation. Yes, we got it. 45x squared minus 10x cubic. Then the second question says determine the value of x. You see, want the value of x, just the x, for which the box will have a maximum volume. We do not want the maximum volume. We want to know the value of x that will maximize the volume. So you must read the question and understand it. So I want to say, okay, fine. This is the second question. The second question we're going to say, for maximum volume, the derivative of that function should always be equal to 0. It's calculus. We are now using calculus. So it means you have to differentiate the function, the volume function, with respect to x. Since we don't have any variable that is the denominator, can differentiate. dv over dx should always be equal to 0. So let's differentiate. This gives us 90x minus 3 times 10, this is 30x squared equals to 0. So we have to solve for x. That will give us the maximum volume. So solving for x here, we can take common factor. Let's just take a common factor of x. Then we're going to remain with 90 minus 30x equals to 0, sorry. X equals to 0, or 90 minus 30x is 0. So we're going to say x equals to 0 or 90 equals to 30x. So we divide everything by 30. Then what is the value of x? So it's 90 divided by 30. Then this gives us x is 3 unit. Then now between the 0 and the 3, which one will actually give us the maximum volume, not the minimum volume? We can do this in 2 ways. That's why I said there's a part where we have to introduce second derivative test. One way would be, we can take these values of x, we substitute into the equation of the volume. We check which one gives us the highest volume. Obviously, this will not be the answer. Because if x is 0, the volume will be 0. So it means to get a maximum volume, you must use x should be 3. Another way will be to use what you call second derivative test, because we know if you make second derivative test is bigger than 0, that's where we have the local maximum point. But if the second derivative is actually less than 0, then that's where we have a local minimum. No. This one is local minimum, and this one is local maximum. I apologize. Because when the second derivative is bigger than 0, the parabola we're going to have the parabola will have a smile face. And since it has a smile face, it means we'll have the minimum turning point. And the second derivative less than zero, it means in terms of a parabola, it will have a set face which will give us a maximum turning point. So in other words, since this is the first derivative of a volume, we got it to be 90x minus 30x squared. So if we differentiate this for the second time, this will be 90 minus 60x. So where there is x, if you put 0 here, so when the second derivative adds 0, this will give us 90. You see that is bigger than 0. And when the second derivative at 30, at 3, this will give us minus 90. It will be less than 0. So we know if the second derivative is less than 0, it shows that the value that we used here, it is the one that will give us the maximum. So this is the maximum. So it means the value of x is the maximum and the value of 0, it is the minimum. It will give us a minimum volume actually. But you don't have to worry about that actually for now. Right, so it means the value of x there is equals to 3. Then we can move on to the next question. The next question says, hence calculate the volume. Okay, now it means now we have to calculate the volume. And how to do that? We're going to say, okay, already we know the value of x that will maximize the volume. Then now we're going to calculate the volume. Where there is x, we're going to substitute by 3. So we're going to say this number C. Maximum volume now. What will be the maximum volume? So it means where there is volume, we substitute by 3. So we're going to have 45 into 3 squared minus 10 into 3 cubed. We substitute into the original equation for the volume. So 45 into 10 squared minus 10 into, okay, not 10 squared, 3, I apologize guys. 3 squared into 10 into 3 cubic. 45 into 3 squared minus 10 into 3 cubic. And this gives us a volume of 135 unit cubic or cubic unit. I believe you guys are following. Then now, moving on to the next question. So it's just a matter of calculus, guys. It's just a matter of calculus. So this will be part 1 actually. So it means I'll also go through this, create another video for part 2. I hope guys you are following. I hope you guys you are following. I hope you are following. Okay. Then now we can move on. So that the other one says, calculate the total surface area. Actually, they're supposed to say determine the total surface area in terms of x. And they say determine the value of x for which the box will have a maximum surface area and hence determine the maximum surface area. Guys, I think here I want you guys to go through this question on your own. You want you to determine, you get the total surface area in terms of x. And you also determine the value of x that will maximize that total surface area. And you also determine that total surface area. Then we'll do the correction in the next section of part 2. I'll address that. And then now, again, the other part is the issue of the right circular cone. However, I'm not going to go through this. I will just guide you so that you go and do the questions, but you see the solution in part 2. So in this one, it says the diagram represents a right circular cone of height h and a base of radius r. So we're given the base is r and the height is h. But they say if the sum of the height and the radius base is 12, if you add the height and the radius of the base is 12, express the r in terms of h. I think you can do that. Then it says express the volume of the cone in terms of h. In terms of h. Express the volume of the cone in terms of h, and also determine the maximum volume of that cone. Remember, what is the volume? How do we remember the volume of a cone? If we know the volume of a cylinder, is pi r squared h. So it means the volume of the cone, as I said, it's 1/3 of the volume of a cylinder, which is just 1/3 pi r squared h. So you can be able to rearrange this and maximize that. So I believe you guys are following. So you must try that on your own. Then I will share part 2 of this video. That's where I will be doing the corrections with you. Okay, then now the next one, it says a container shaped in the form of a cylinder. A container shaped in the form of a cylinder with no top, and it's very important. With no top, has a volume of 340 milliliters. So we're given a volume of 340 milliliters. And we are told that this cylinder has no top, has no lid. Guys, I want you to go through these on your own and try to analyze this. It has a radius of x. So the radius is x centimeter. And the height, it's h centimeter. But we are told that 1 milliliter is equals to 1 centimeter cube, which means if the volume is 340 milliliters, it's still the same as 340 centimeter cubic. So this is a cylinder, and this cylinder has no lid. There's no top. They told you. And the first question says, write down the height in terms of x. You need to write the height in terms of x. I want you to go through that and do this on your own. Then the second one says, show that the surface area S of this cylinder with no top is given by this. And the last one says, calculate the value of x for which the surface area of this will be a minimum. You can also add this and say, hence determine that surface area. So you want to know the value of x that will actually minimize the surface area. So you can go through this on your own. Then this is questions that are involving graphs. So we're gonna talk about this in the next session, where we also address the rate of change. So this will be part 2, and also the calculus of motion. Yes. Okay. Thank you very much for listening, guys. See you in the next part of optimization. Kindly don't forget to like, subscribe, and share. Enjoy your day. Thank you very much. Bye.